All right, our final lesson in this unit deals with spheres. We're going to find the surface area and the volume for spheres. And that's going to require that we do a little bit of thinking and problem solving. We're going to have two formulas, all right? We haven't had to do that yet. And we're going to write these formulas so many times you're going to know them by the end of the notes. If you are thinking about it and if you're writing them down, then you should be good to go. There is some key vocabulary around the sphere that we want to make sure that we know and understand. A sphere is the three-dimensional object and all of the points that are the same distance from that center, but in space, not just on a plane. That would be a circle, right? And so in space, if we have all these points that are the same distance from that center, all those dots would together make what we would call the sphere. The center is that point from which all those other points are equidistant. The radius is that distance. It's a segment that it measures only that distance, and the diameter is that segment that passes through the center but has endpoints on the sphere. So similar vocabulary to a circle, we have that same vocabulary here for a sphere. There is, in a sphere, there is something called a great circle. And that is not just any cross-section. We talked about cross-sectional analysis of some of these figures back in lesson 1. And if you draw or take a plane and you cut through a sphere, varying degrees and angles, whatever else, it's going to carve out a circle, right? Because that would be the cross-section of a sphere. But a great circle is the cross-section of that plane that passes through the center of the sphere. That would be the great circle. So like drawing, if we're looking at the globe, then the great circle would be like the equator, right? Because that would be that biggest circle there. If we were just doing like, the Arctic Circle, it's just this little dinky circle up there, that's not the great circle, right? It's not the biggest circle that we can possibly get when we are talking about the sphere. So the great circle is what you get, is the circle shape that you get when you cut a plane through the center. The circumference of that great circle is the circumference of the sphere. And obviously half of a sphere, we don't call that a semi-sphere, we call it a hemisphere. All right, so that's the word there, hemisphere. Not new vocabulary by any means, but in case it is, there you go. All right, so again, the great circle cuts the sphere into the two hemispheres. The circumference of that great circle is the circumference of the sphere. So hopefully that makes sense to us in that vocabulary side. And then here are our formulas. We've got 4/3 times pi r cubed. Another way to write this is 4 pi r cubed over 3. All right? That's another way to write that if that becomes an issue when you're working with your calculator and you end up doing this kind of fraction math where you have to multiply this by 4 and then divide by 3. If it divides by 3, then this works out nicely. If it doesn't divide by 3, then guess what? It's going in the numerator with the 4 and the pi. So just kind of keep that straight when we are following our orders of operations and how we multiply with fractions when there's whole numbers and variables and such involved. The surface area of a sphere is really, it's the derivative of the volume, which is kind of interesting. It is 4 times pi times the radius squared, all right? And so these two formulas, you're gonna write a bunch right now and then again in class, and that should be a pretty manageable feat. So here is an example. Go ahead and pause it and see if you can do letter A here. See if you can determine the radius and then use that radius to find the surface area. So the surface area again is 4 times pi times the radius squared. The radius here is going to be half of this diameter. It's going to be 9. Pause the video if you want to do that work on your own. Otherwise, I'm just going to do it for you. And so we have 4 times pi times 9 squared, or 4 times pi times 81, and we get 324 pi square feet. All right, the feet are times each other. So 9 feet times 9 feet gives us feet squared. For the volume, 4/3 pi r cubed, we will have 4/3 times pi times 9 cubed. Here we know that 9 is divisible by 3, so that means that 9 cubed will also be divisible by 3. And so we're going to end up with 972 pi feet cubed, or cubic feet. Doing that computation doesn't have to be rocket science. What we can make sure that we do is, if we're using our calculator, 4 divided by 3 times 9 to the 3rd power, it will calculate that for us, all right? How do I get that exponent? Well, you can do this 2 different ways. You can either do 4 divided by 4 divided by 3 times 9, and then this little button right here on either calculator takes it to that power, and then you can type that power. Or if you are not big in exponents, then you can do times 9 times 9 times 9, and it will also give us that output. When we're working in terms of pi, you have to know to tack that pi back onto the end of things. Go ahead and try this one. The surface area of this ball with a diameter of 30 centimeters or a radius of 15 centimeters means that when we do 4 times pi times the radius squared, we get 4 times pi times 225, which gives us 900 pi square centimeters. For volume, 4/3 times pi times the radius of 15 cubed, so 15 times 15 times 15, but then divided by 3 and then multiplied by 4 and pi, gives us a really big number of pi, right? 4,500 pi cubic centimeters. Again, let your calculator do that work that it can do so that you don't have to do this mental math or whatnot. Again, your job is to make sure that you can write formulas, plug in numbers, calculate values. Are you able to do that? Hopefully the answer is yes. If so, then you can find the volume and surface area of spheres.